All right, let's try this out. This is super weird, but it's the best that we got right now. I guess it should be mostly interruption free. Don't need to pass if you got to go to the bathroom. Just pause the video. And here's the thing, I'm thinking that I can post your notes and post this video down in the discussion area. I'm going to give that a try. But what you should do is have access to your notes as we're going through the lesson. And I'm recommending that you write those notes out. Or if you have a printer, you can think there's something good about writing them out. You should also, kind of as we're working through this, have access to your special triangles. Don't know if you can see them up here, but I don't need the board space right now. I've got what we know is a 45, 45, 90 triangle, also a pi over 4, pi over 4, pi over 2, pi over 6, pi over 3, 90 triangle. And that might be helpful to us. This video is entitled 4.2b because we started this actually when we were all together last week. And I want to remind you of some stuff really quick. If we have a unit circle, and remember, a unit circle is a circle whose radius is 1, and we have an angle that is in standard position as the terminal side of the angle passes through the unit circle. It has an x and y value, and we're going to look at that up on the board. I showed you last week how I could prove to you using kind of some right triangles that the x value where this passes through the unit circle is actually the cosine of this angle theta, and the y value is actually the sine of theta. And that means if we have any angle theta and we can place it on a unit circle and we can know where the terminal side passes through the unit circle, we can know the x and the y, we can pretty much give all of the 6 trig functions for a theta. Here's the thing that you got to be really careful about. See, this angle, I could draw these rays on and on and on forever. It's very conceivable that this particular angle, the terminal side, would pass through the point 2, 3 way later on. That doesn't mean that the cosine of this angle is 2 and that the sine is 3. That only works at the point that it passes through the unit circle, if we were to shrink down to that point. So we'll figure out how to solve those using some right triangles, but for now, we're just focusing on the unit circle. We did this together the other day. I figure let's just kind of practice and get back into it by doing an example together. So I'm taking the example out of the book. Don't know if you're able to have a copy of the book open as well, but I'm somewhere. On page 510, looking down at the bottom of page 510 at checkpoint 1, it gives me an angle, and it passes through the unit circle in the first quadrant, and the x and y coordinates are √3/2 and 1/2. And we're asked to find the 6 trigonometric ratios. So we're looking for cosine of theta. We don't even know what theta is, but we can know its cosine based on what we've learned about the unit circle. That's just the x value, right? So I look up there, I see the x value is √3/2. Done. Sine theta is just the y value. So I'm done with that as well. And hopefully you remember I showed you tangent theta. We can show is the y over the x, or another way of saying that is the sine of theta over the cosine of theta. So that would be 1/2 divided by √3/2. And remember, to divide fractions, I would invert and multiply. So this would become times 2/√3. And when I do that, I see my 2's cancel out, and I just have 1 over square root 3. And I can't keep things like that. We know how to deal with that. Square root 3 over square root 3. I get square root 3 over 3. That's the tangent of this angle theta. Then we remember the other 3 all relate to these 3. So hopefully you remember what the inverse of cosine is. The flip of cosine is secant. So it doesn't matter what order we do them, but secant theta will become 2 over root 3. And again, we have to clean that up a little bit. Square root 3 over square root 3 equals 2 root 3 over 3. Cosecant theta is a lot simpler. 2 over 1, that's just 2. And finally, the cotan of theta is the flip of tangent. And so if I flip that, let's go right to the end. We found tangent was 2 root 3 over 3. That becomes 3 over 2 root 3. And I could clean that up with a square root 3 over square root 3. What I get is 3 square root 3 over 2 times 3. And rather than write that out as 6, I left it as 2 times 3 because hopefully you can see that the 3's are going to cancel out. Root 3 over 2. There's going to be homework questions that are similar to this. You can go ahead and pause the video now and practice some of those. I want to move on and look at a couple of other things on this video. So, if you want to pause it and practice, that's great. If you want to keep going, I want to show you how we can use this information about the unit circle now. We could handle angles that are greater than 90 degrees. We couldn't do that with right triangle trigonometry. We can also handle an angle like 90 degrees. We couldn't do before, but let's work through the 6 trig functions of a 90 degree or pi over 2 angle, because we're going to use the unit circle instead of SOHCAHTOA. So if I were to have an angle, a 90 degree or pi over 2 angle, again, this is the initial side, and there's the terminal side. And remember, I'm looking for where it passes through the unit circle. Well, what's the X and Y coordinate there? 0, 1. And so keeping in mind cosine theta is just the X coordinate, the cosine of pi over 2 or 90 degrees is simply 0. Sine of pi over 2 is 1. Now, tangent of pi over 2 may be a little tricky because I'm supposed to do y over x or sine over cosine. 1 over 0. Hopefully, remember, we can't do that. We can't have 0 in the denominator. So turns out tangent of pi over 2 or tangent of 90 degrees, we would say, is undefined. Actually can't graph it. We'll see that a little bit later on. Same thing if we go down to look at secant. Secant is 1 over cosine or 1 over 0, also undefined. Cosecant, 1 over sine, the flip of sine. Sine is 1 over 1. If we flip that, still get 1 over 1 or 1. Now, cotangent is the flip of tangent. Remember, tangent originally was 1 over 0. So if I flip that, I actually get a fraction that I can work with. 0 over 1, I can do. I have 1 in the denominator, not a 0. And the value of cotangent is 0. So using the unit circle gives us flexibility to find some angles like that. We could do the same thing with 180 degrees or pi radians. And we'll get to explore some of those in our homework questions as well. I want to talk to you at the end of this video about what we call trig identities. Identities are just truths, facts, and they're essentially two values that are equivalent to each other. Like we know that secant is equal to 1 over cosine, or cosine is equal to 1 over secant. Those are all identities. And so we know how secant and cosine relate to each other, how sine and cosecant relate to each other, how tangent and cotangent relate to each other. We also learned some identities such as tangent of theta is sine divided by cosine. Sometimes that's called a quotient identity. Tangent equals sine divided by cosine. Cotangent is cosine divided by sine. I want to show you some other significant ones. At least one of them have listed in your notes. They're called Pythagorean identities. I think you'll understand kind of how we get to them, but I have one written in your notes. The other two, we're going to kind of derive them, and you should probably include those in your notes as well. We're going back to our unit circle. If you remember, the way we came up with some of this stuff about the unit circle was I kind of picked the point where the terminal side pierced through the unit circle and dropped a line straight down and created a right triangle for us. And using that information, we remember that this side of the triangle is essentially the x value. And when I do adjacent over hypotenuse, remember the length of the hypotenuse is 1. So this is cosine here. We knew that the y value is the sine value. I want you to think about the Pythagorean theorem when it comes to sine and cosine. A squared plus b squared equals c squared. You guys remember that. Well, if I plug in what I have here, cosine theta squared, we got to be careful here. I put a little something in your notes. When I say cosine theta squared, I mean this whole side times itself. I mean cosine theta times cosine theta. If I were to try to write that like that, I might get a little confused and think, oh, first I'm just supposed to square this angle, then find the cosine. It doesn't mean that. It means find the cosine and multiply that by itself. So I guess we could use parentheses, but one way that they get away with not using parentheses but still being clear on what they're talking about, and we're going to use this notation, is to write it like that: cosine squared theta. That means cosine theta times cosine theta, which is exactly side A is cosine theta. So let's go back up here. Cosine squared theta plus this side squared, sine squared theta equals c squared, but see, the hypotenuse is length 1. This is a unit circle, and 1 squared is 1. So for any angle, this is going to be true. If I take the cosine and square it, if I take the sine and square it and add them together, I'm always going to get 1. That's an important identity that's going to help us to solve some problems. Really quickly, and you can pause, you can go back and check over this. I'd like you to write out 2 other identities that come from this. This is an equation here, and I can divide an equation by anything I want, as long as I do it to every term on both sides. So what if I just decided to divide every term in this equation by cosine squared theta? Just watch for a second. Now, that might look like a mess, but you know how to simplify this because you know some other identities. First fraction, look, I've got the exact same thing on the top and the bottom. Cosine squared theta over cosine squared theta. That's just 1. Now, this second one, sine squared theta over cosine squared theta, that means sine times sine over cosine times cosine. And what is sine over cosine? Guys, remember that's what tangent is. So this is actually tangent times tangent, or tangent squared theta, right? 1 over cosine squared theta is 1 over cosine times 1 over cosine. But what is 1 over cosine? Isn't that secant? So this equation is also a valid equation, and it's also called a trigonometric identity. If I took the secant of theta and squared it, it would be equal to 1 plus tan squared theta. All right, put that one in your notes. That's not a bad one to box in. I want to do something similar and come up with one more. What if now I decided, hey, I'd like to divide all these by sine squared theta? So let's look at that first fraction. Cosine squared theta divided by sine squared theta is cosine times cosine over sine times sine. And I could break that up into cosine over sine times cosine over sine. What is cosine over sine? That's cotangent. Sine squared over sine squared, 1. About 1 over sine squared. That's going to be 1 over sine times 1 over sine, or cosecant squared theta. So do me a favor, keep both of those in your notes as well. We're actually going to get to make use of some of these, and I want to run through one problem on this before we bring an end to this video and give you a chance to practice some on your homework. I'm swinging over to page 515 and looking at example number 6. And I'd love you to take a look at that example in your book because there's something that might intimidate you in your homework. Here's what it says. It's given that sine of angle T, instead of saying theta, they're just going to use the letter T, equals 3/5. And then it says something that might look intimidating. It says 0 less than equal to T less than equal to pi over 2. Find the value of cosine T using a trigonometric identity. Let me write those on the board. We'll take a look at what it says. Sine T equals 3/5. And please don't get concerned or messed up if they're using a T instead of a theta. We could use an X, a T, a theta, any of those just represent an angle we don't know. And so I know that the sine of this angle is 3/5, okay? And then they tell me one more thing. That's just really another way of saying that t is in the first quadrant. Look, it says t is greater than 0, less than or equal to pi over 2. Pi over 2, if we're talking in degrees, is 90 degrees. So it's saying t is somewhere between 0 and 90 degrees. That's going to be important mostly just to know if our values are positive or negative. And so what they're asking is, hey, let's find the cosine of this angle t that's in the first quadrant. I know in the first quadrant, there's a teeny little unit circle. My angle, I'm talking about the x and y values are sine and cosine when I do a unit circle. And so can you understand why I know both of those are going to be positive? By them telling me it's in the first quadrant, those are going to be positive. And we'll go from there. Come on in, Abby. I got a visitor. We're actually recording a lesson. How are you? Your binder is over there, and hopefully your book is over there. And isn't this fun? I'm too invested in my video to start over, so make sure you keep checking in each day. Hopefully life is going well for you. Good. Awesome. See you later. All right. So I know that sine and cosine are both going to be positive. I'm going to use that Pythagorean identity that says this. Sine squared theta, or t, plus cosine squared theta, or t, equals 1. All right. I'm told that sine is sine of theta, or t, is 3/5. So 3/5 squared plus cosine squared t equals 1. And 3/5 squared, hopefully we have no problem doing that. That means 3/5 times 3/5. So I'm going to get 9/25 plus cosine squared t equals 1. All right, I'm trying to solve for the cosine. So let's subtract 9/25 from both sides. Cosine squared t equals 1 minus 9/25. I like common denominators. You guys are getting good at this. Hopefully you know 1 is 25/25. So that would mean that cosine squared t is 25 minus 9, which is 16/25. By the way, this is rough to do when I have no one in here because I'm going to make mistakes and then I have no one to point them out to me. You can point them out on discussion if I make a mistake, and hopefully I'm going to do my best not to make any. I'm not looking for a cosine squared. I'm looking for a cosine. And so the best thing to do would be to square root. I have to square root both sides. And let me bring it up over here. That square root and that square are just going to cancel out. I have cosine t equals the square root of 16/25, which hopefully you remember this about square roots, but if not, start to remember it again. I can split that radical up to the top and bottom. Square root 16 over square root 25, which is 4/5. So sine was 3/5. Cosine of angle t is 4/5. We're going to stop the video there. You can tackle some of the homework questions that have to do with that, and we'll pick up with the end of the lesson in a little bit.